Hello, this is Mr. Henry, and welcome to lesson 13.4. In this lesson, we're talking about compound events. The essential question says, how do I find the probability of a compound event? Now, we have a Get the Goof down below, and it says, you sing in a chorus after school. The director will choose 2 songs at random out of 5 for the chorus to sing. What is the probability the director will choose your 2 favorite songs? The first thing we got to think about is, are we talking about a permutation or a combination? Does it matter the order the director picks the songs? I don't think so. It just wants to know your 2 favorite songs. So if it doesn't matter the order, it's not a permutation. It would be a combination. Now, here's the formula, and it looks like there's some stuff not right in this formula. So that would be some of the mistake. Let me slide this guy over here. The correct formula would be, 5 choose 2 would be 5 factorial over 5 minus 2 factorial times by another 2 factorial. So they have their 5 and their 2 kind of reversed. Now 5 factorial, let me see, this is 3 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1 over 3 factorial times by 2 factorial. The 3 factorials will cancel out because they're both just equal to 3 times 2 times 1. So you get a 20 over 2, which gives you 10. Now, that 10 is not the probability. That's just how many ways you can pick 2 of those songs out of the 5. So the probability would be a 1 out of 10. There's only one way you're going to get the 2 songs as the 2 songs that he picks. We've got quite a few vocab words, 5 vocab words here. So starting at the top, a compound event. A compound event is when you have 2 or more events happening together. So it's 2 or more events. And a lot of times you'll see this thing and another thing or. So rolling a dice and flipping a coin, or rolling a dice rolling a 3 or a 4. Those are compound events. 2 events are called mutually exclusive if they have no common outcomes. Example, the probability of rolling a 5 on a dice or a 3 on a dice. I mean, if I roll a 5 or a 3, those 2 things are very separate. But overlapping events, by comparison, have at least one common outcome. Now this might be an example of rolling an even number, or a number bigger than 5. So for example, even numbers, 2, 4, 6. Number bigger than 5, 5 and 6. Do you see how they have a common number, 6? So this would be called overlapping because they share a common number. And so you just got to be careful when you're talking about compound events, more than one thing happening. You got to make sure they don't have any of these overlapping. And if they do, you think about it. 2 more vocab words. First of them is independent. 2 events are considered independent if one event has no effect on the other. An example, rolling a dice and flipping a coin. The fact you roll that dice does not change the probabilities of getting heads or tails on that coin. So those 2 events are independent. One does not affect the other. 2 events are dependent if one event does affect another. An example might be if you had, say, a bag of marbles or something like that, and if you pull a marble out, so if you say that what's the probability of pulling out a blue marble? Well, 3 out of whatever. Now if you take one marble and you pull it out, now the probability changes. Probability of getting a blue marble right now would be 3 out of 4. If I pick out a marble, now it would be 3 out of 3. So the fact if I take this marble out and I leave it out, that changes the probabilities of everything else in that bag. So that would be dependent. The second event depends on what happens the first time. So let's see some examples. The first thing we got here is we have probability. It says, what is the probability of rolling a 2 or an odd number? So let's make sure that these things don't overlap. 2 or odd. Well, the odd numbers on a number cube would be 1, 3, and 5. Okay, so they don't overlap. So now let's think about this. Think about the sides of a number cube. How many of them are 2, 1, 3, or 5? 4. That's 4 of the sides out of a total of 6, which is 2/3. When you're talking about probability, you find the if you're finding the probability of 2 different events. If you have an or, you take the probability of the first plus the probability of the second and add them together. Letter B. What is the probability of rolling an even number or a prime number? So even or prime. Now, even numbers would be 2, 4, and 6. What are my prime numbers? Prime numbers are things that don't have any factors except 1 and itself. So in this case, 2 is prime, 3 is prime, 5 is prime, and that would be it. Because something can multiply, 2 and 2 can multiply, get 4, 6 is 2 and 3. The only thing that gets 5 is 1 and 5. The only thing that becomes 3 is 1 and 3. The only thing that multiplies get 2 is 1 and 2. And for whatever reason, 1 is not considered a prime number. So these are all of our prime numbers. So if you think about it, we've got 1, 2, 3, 4, 5 different possibilities out of the 6. The only number that's not being counted here is a 1. I mean 1, 2, 3, 4, 5, 6. So 5 out of the 6 numbers are either an even number or a prime number. The only number that's not is 1. This would be an example of those overlapping events where 2 was in both places. And the way you can think about this, if you like using formulas, it's the probability of the first. Or I should say, let me try that again. It is 1/2, but I'm simplifying in my head. 3 out of 6 for the first, 3 out of 6 for the second, minus how many things are overlapping? How many things are in both categories? Well, 1 out of the 6. You do this math, 3 plus 3 is 6, minus 1 is 5, denominator stays the same. We get the same answer, it's just this way is kind of using formulas. Oopsie. This way is using your formula, and the top way is thinking about it kind of logically, the way you'd interpret it in your brain. Okay? Please try letter C. It says Sabrina rolls a number cube. What is the probability she rolls an even number or an odd number? Go ahead, pause the video right now. When you're ready to continue, hit play, and we'll go through it together. Okay, so we want the probability of an even or odd. So an even number, it's 2, 4, 6. Odd number, 1, 3, 5. They don't have anything in common, so this is 3 out of 6, or 3 out of 6, which is 6 out of 6, which equals 1. So there's basically a 100% chance on a number cube Sabrina's going to roll an even or an odd number. And that should make sense. That should be what you think it should be. That's the only numbers on a number cube are even or odd. Okay? I would like you to I'd like you to do 2 problems from the textbook. These come from page 862, numbers 1 and 2. Go ahead, pause the video, do them right now. When you're ready to continue, hit play, and we'll go through them together. Okay, number 1 says, you roll a number cube, all right, Find the probability that you roll a 2 or a 5. So we want the probability of a 2 or 5. Now, there's only one 2 on a number cube. There's only one 5 on a number cube. So we want this thing or the other thing. We add those probabilities together, and we get 2 out of 6. Number 2. I'm sorry, I can simplify. 1/3. Number 2. You roll a number cube. Find the probability you roll a number less than 4, or an odd. Okay, so probability of less than 4 or odd. So numbers less than 4 are 1, 2, 3. And odd numbers are 1, 3, 5. Now you'll notice we have some overlapping here. 1 and 3 are in both lists. So we're going to have to do a little bit of that thinking about which things are not being counted. So here, this would be a 3 out of 6, 3 out of 6. But how many of them are overlapping? How many are in both categories? Well, 2 out of 6. So 3 out of 6 plus 3 out of 6 would be 6 out of 6. Minus 2 out of 6 would be 4 out of 6, not 4 out of 4. 4 out of 6, which would be 2/3. Now let's double check, make sure. So what numbers are less than 4 or odd? Well, 1, 2, 3, 5. The numbers that don't count, 6 and 4. 6 and 4 are not less than 4, and they're not odd. So these are the numbers that work. That's the 4 from there. 4 out of 6. So a lot of the times you can even write it out like I did here and think about it logically. There's also the formula way. Now the next thing we're going to look at are these, what happens with independent and dependent events. So what I have here is a picture of a fish tank with some different colors of fishes in it. And I want to show you what it means to do probabilities with and without replacement. Because you'll see that occasionally in your math problems. They'll say, well, what's the probability of picking a green fish with replacement? Or what's the probability of picking a green fish without replacement? I guess I should say picking 2 green fish. So let's see. With replacement means the probability of a green and another green with replacement. So right now, what's the chance of getting a green fish? 4 out of 9. Now, imagine I take one fish, I pull it out, yep, it's green, and I put it back in. I replaced the fish. What's the chance of getting another green fish? Well, 4 out of 9. And we're going to multiply these together because you have 2 different events. Every time in probability you have 2 different actions or 2 different events, you multiply the probabilities together. So the chance of getting 2 green fish with replacement would be 16 out of 81. Now, if we're talking about without replacement, probability of a green fish and another green fish. Now think about this. First off, what's the chance of getting a green fish? From the fish tank, it's 4 out of 9. Now, let's say we take one green fish, we take it out, and we leave it out. Go. Now, that fish is not going to be replaced. So now, what's the probability of getting another green fish? Now there's only 3 green fish, and in my fish tank there's only 8 fish. So this would be a dependent event because the chance of getting another green fish depended on what happened the first time. In fact, the probabilities of all the fish have changed, because now instead of being 9 fish in the fish tank, there's only 8. So when you multiply here, you're going to get 12 up top and 72 down below, and you simplify to be, what, 1 out of 6? I'm doing the math. Let's see. That's 1, that's 2, that's 1, that's 3. Yeah, 1 out of 6. Okay. So without replacement is dependent because it's changing the probabilities of all the other fish in the fish tank. With replacement is independent because each time you just keep putting that fish back in so all the probabilities don't change. So here we have an example. It says you have a bag of marbles that contains 2 red, 1 blue, and 4 green marbles. Find the probabilities, or find the given probabilities. So the first one says, what is the probability of picking a green marble and a blue marble with replacement? All right, so I want the probability of a green and blue with replacement. So chance of getting a green marble. 4 out of, how many are total? 4, 5, 6, 7. 4 out of 7. Now, imagine I take 1 green marble out, I look at it, and I put it back in the container, back in the bag. So the chance of getting a blue marble is going to be 1 out of 7. There's still 7 marbles in that bag because I took 1 out and then I put it back. And because we have 2 different actions, you have to reach into that bag 2 different times, you're going to multiply those probabilities together and you get 4 out of 49. And that doesn't simplify. Letter B. What is the probability of picking a green marble and a blue marble without replacement? So now it's the same scenario, except now we're not replacing. So we want the probability of a green and blue without replacing. So again, the chance of getting a green marble from that bag at the beginning of the scenario is 4 out of the 7. Okay, so come on, scroll down. There we go. 4 out of 7. Now, imagine you took 1 green marble out and you set it aside. How many blue marbles are there? Well, there's still 1 blue marble, but how many total marbles are there? Now there's only 6 because you took 1 of those green marbles out and you put it aside. So now there'd only be 3 green marbles left in that bag. So instead of the probability of blue being 1 out of 7, it's 1 out of 6. And again, 2 different actions, multiply them together, and you get 4 out of 42, which simplifies to be 2 out of 21. So with replacement, the probabilities remain the same. Without replacement, the probabilities change. Especially, well, mostly the bottom number, the total amount changes. But also, find the probability of 2 greens, it'd be 4 out of 7 for the first one, and only be 3 out of 6 for the second one, because now there's less green marbles. Same scenario. Could you please answer this question? What is the probability of picking a red and a green marble with replacement? Go ahead right now, pause the video, do this on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so we want the probability of a red and green. So the probability of a red marble is 2 out of the 7. Now, we are replacing with replacement, so that means we're putting the marble back. So there's still a total of 7. And there are 4 green ones. 2 actions means you multiply. We get 8 out of 49, and that does not simplify. So hopefully you see the difference between with replacement and without replacement. Now, the next thing we're going to look at here is a little bit more of the same sort of problem. It says a box contains 3 blue pens and 5 black pens. You choose one pen at random, do not replace it, then choose a second pen at random. Okay? What is the probability both pens are blue? So we want the probability of blue and another blue without replacement. So we are not replacing the pen. Okay, so the chance of getting the first blue is 3 out of 8. 3 blue, 8 total, because there's 3 and 5. Now, the chance of getting the second blue, I've taken one of these blues out and I have not replaced it, which means now there's only 2 blues left in the bag, or the box, and 7 total. Multiplying together gives us 6 out of 56, which gives us 3 out of 28. So there's a 3 out of 28 chance of getting 2 blue pens without replacement. Letter B. What is the probability one pen is blue and the other is black? So we're back to the beginning of the scenario. 1 pen blue, 1 pen black. All right, so probability of a blue one and a black one. So the chance of getting a blue pen at the beginning of the scenario is again 3 out of 8. There's 3 blue ones, 8 total. Now imagine you take 1 blue one out and don't replace it. Now what's the probability of getting a black pen? Well, there's 5 black pens, and how many total? There's only 7 total. 5 and 2 blue pens. Remember, we took 1 blue pen out and we did not replace it. We multiply together, 15 over 56, and I'm pretty sure that does not simplify. So that would be done. So we are not replacing. So you're taking it out and you're leaving it out, which makes the total now down to 7 pens altogether. Letter C, I'd like you to do on your own. It asks, what is the probability? Now here, it's just the 3 blue pens, 5 black pens. What is the probability you pull 3 pens that are blue from the box with replacement? Go ahead, pause the video right now, do that problem on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so you want the probability of blue and blue and blue. Yes, I know black also starts with BL, but we're blue, blue, blue here. So, chance of getting a blue for the first one is 3 out of 8. Now, since we're talking about with replacement, you put the pen back. So, since you put that blue pen back in, how many blue pens are there? 3 out of 8. And you put that one back in. 3 out of 8. And you get 3 out of 8 times 3 out of 8 times 3 out of 8. Since you have different actions happening, you multiply them together. You get 9 out of 512. And that does not simplify. So with replacement, stays the same. Without replacement, you're reducing the number each time you pull it out and you do not replace it. Here is example, or I say the now your turn, number 3 on page 863. It says a bag contains 4 red, 5 green, and 2 blue marbles. You randomly draw 2 marbles, one at a time. Find the probability that both are red if, part A, if you replace the first marble, and then part B says if you don't replace it. Pause the video right now, do it on your own. When you're ready to continue, hit play, and we'll go through it together. So in part A, you are replacing. So you want the probability of 2 red marbles. Red and red. The first scenario, you are replacing. So the chance of getting a red marble was 4 out of 4, 9, 10, 11. Now, since you took one marble out, you looked at it, you put it back, there's still 11 marbles, and 4 of them are red. Multiplying out gives you 16 out of 121. Now, the second part says you do not replace the first marble. So now we're saying, okay, what happens if you get red and you do not replace? So the chance of getting a red at the beginning of the scenario is 4 out of 11. Now, you take one red marble out, and you leave it out, which means now there's only 10 marbles in the bag. 3 of them are red, because you already took one red one out. So now the probability is not 7. How did I get 7? I added instead of multiplied. Probability is 12 out of 110. And that does simplify, and you get, what, 6 out of 55? I think that's it. So you can see the probabilities are not the same with replacement and without replacement. Without replacement, the number changes. With replacement, it stays the same. If you could please take a second, pause the video, answer this question. It says, how do you find the probability of compound events? Now, we've talked about a couple different types of compound. We talked about independent events, dependent events. Independent and dependent are the with and without replacement. We also talked about overlapping events, where you could have like the probability of an even number and a number less than 6 on a dice, how some of those are overlapping. So go ahead, answer your questions best you can, pause the video, and when you're ready to continue, hit play, and we'll go through it together. Alright, here's what I said. I said, determine if the events are overlapping or exclusive, meaning they have something in common or they have nothing in common. Then, if only one action is happening, you add the probabilities together. So, for example, the probability of rolling a 3 or 5 on a dice. That's only one action. You're just rolling dice one time, you want a 3 or a 5, so you add the probabilities together. 1 6 plus 1 6 is 2 6, which is 1/3. If there's more than one action happening, you multiply the probabilities. So that would be like the probability of a green marble from the bag and then a red marble from the bag. You do one action, then another, so you multiply their probabilities together, and that's what you get. Homework comes from page 864, numbers 3 through 12, and 14 through 16. Make sure you show your work. This has been lesson 13.4. Thank you for watching. Bye-bye.